So a short note on using the VUopamp model in Ltspice. I have this already set up, the schematic, so we're just going to drop down the VUopamp here, add a component. Now the normal directory is the system directory here. We're going to look in our local folder. If you notice, VUopamp, the symbol and the library that includes the model is right in the same directory. That's where it has to be for us. VUopamp is the only thing there. Now if we look at this, our op-amp has the plus and the minus this way, and the power supplies are plus and minus and plus. That's not what we want. We want this plus to go in here. This is for problem 3 in Connect. So I'm just going to select this. I'm going to say move, which is Control W. Click it, so I grab it. Control E is mirror, flips it over, and then rotate twice. And now we have our op-amp flipped around. You can move it down, drop it, and connect it so we have it as a non-inverting op-amp structure. We need to add our power supplies here. I named these nodes. This node is V plus in the upper left, V minus down here, 15 volt plus and minus power supplies. Add a note, or add a label to net so I don't have to draw the wires. I can add that label by also doing the shortcut E. So E, label that, V plus, and V plus is down on the bottom this time, be careful. And E again, V minus, click, down, escape, we're good. Right now we already have a op-amp thing here. Draw there, or a dot op symbol, and we're ready to go. Okay. And let's simulate this thing. These numbers, the 54K, the 3K resistor, and the 100 millivolt for the inputs, those were auto-generated numbers from Connect. Your numbers will be different, I'm sure. Simulate, run. It's either run or Control B in our custom shortcuts. So I'm just going to do Control B for begin. .op. If we look at this, we had some options to save the device currents. This is current going into pin 1, into pin 2, into pin 3, 4, and 5. They're not labeled. Which one is V plus, V minus, V out, the power supplies? I don't know. Let's look at this. Right click, open symbol. We look at all this. Yeah, that doesn't really help, does it? Check this out. View Spice netlist. And if we look at the netlist, we see this X component. This X component is our VUopamp. It's a sub-circuit. 1, 2, 3, 4, 5 pins. First pin is V plus, second pin is V minus. If we notice how the nodes are named, V plus, this one, that's the positive power supply. V minus is the negative power supply. Out. So pin 1 is current going into the plus pin, current going in to the minus pin, current going into the output is number 5. So we'll look at our error log, which wasn't useful. Run the simulation again for the operating point. Current going into the plus input, 3.8 femtoamps. Okay. Coming out, 3.8 femtoamps. It's the same because these are in series. There's a resistor in between here. 5, this is current going into the output pin, so it's actually going out because of the negative sign, and it's 33 microamps. I think we're good. Be out, R1, current through all the resistors. Be careful, the resistor currents depends on which way the resistors are down. If you rotate them, remember Ltspice does that too. If you want to know and know which way they go, the netlist R1 is node 1 and node 0. This is into the plus when we say a positive current, which is this, which means the current's going down that way. R2 is oriented so that out is the plus terminal and 1 is the minus terminal, so that's also going down for a positive current. That's how we get the numbers that make sense to us. Both of these are positive. That's how we draw it. One more thing is this has a bunch of parameters. Right click on the symbol opens up the attribute editor. You can see U1, just the name of that part, as the prefix X. We saw that in the netlist. This one is visible. We're going to make all of these other parameters visible because we talk about them in class. This is how to make an ideal op-amp or play with those op-amp parameters that we do in class. So you say, okay, it's a big mess. I'm going to Control W to move all these up, and we want to see them. And we're going to go View, Zoom to Fit. Look at that space bar. So AVOL, right click. Problem, set our open loop gain. 1 mega was my connect version. I think I closed that web page already. And so on. The other one, leave everything else. All these other zeros. I limit, that's something else. Rail, other things, slew rate, phase margin, noise stuff. So the only things we're changing for our models right now is AVOL, that's the open loop gain, or A, and RN. Right now it's set to 500 mega ohms. Right click on it. My connect thing said it was actually 1 mega ohm. I'm going to change that to 1 mega. Now our op amp's going to simulate the same. Run it again, .op. We look here, 1.9 picoamps going into the plus terminal, which is this terminal, and 1.9 picoamps coming out of that because there is a resistor in series with there and no other connections. And our model, everything else is as we do. If you look in Connect, which is in a different operating system at the moment, so I can't show it to you, those are exactly the numbers within the digits of precision that it asks to do. Your numbers will be different because Connect randomly generates all these numbers. Thanks for watching.